Why does a straw look bent in a glass of water? Why do mirrors flip left and right but never up and down? And how can a tiny curved piece of glass make you see things bigger, smaller, upside down, or perfectly sharp? All of that comes from ray optics, how light travels in straight lines and changes direction when it meets different surfaces. Take a flashlight and shine it through a clean glass of water onto the table. You'll see the beam bend slightly as it enters and again as it leaves. Nothing touched the light, yet its path changed. That bending is the entire story of refraction. This is the Learning Studio, turning optics into something you can grasp instantly. Light usually travels in straight lines. That's why shadows are sharp and mirrors work the way they do. But when light meets a surface, two things can happen. Reflection. Light bounces off. The angle it comes in equals the angle it leaves. That's why you see yourself in a mirror. Your light simply returns to your eyes. Smooth surfaces give clear reflections. Rough surfaces scatter light, so you see no image. Now the bending part, refraction. Light changes speed when it travels from one material to another. Air, water, glass, plastic, each has a different optical density. When speed changes, direction changes. Entering water, light slows down and bends toward the normal. Leaving water, it speeds up and bends away from the normal. This is why. A straw looks broken in water, swimming pools look shallower, lenses can focus light into a single point. And lenses are just curved pieces of glass controlling how light refracts. Convex lenses, thicker in the middle, focus light, magnify objects, used in cameras, microscopes, glasses for long-sighted people. Concave lenses, thinner in the middle, spread light out, used in peepholes and glasses for short-sighted people. Put a convex lens in the right position and it forms a real image, upside down on a screen. Move the lens closer and it becomes virtual, upright and magnified. Mirrors behave similarly. Curved mirrors change image size and orientation by bending reflection paths. Once you understand that light travels in straight lines and changes direction only when it reflects or refracts, every optical device suddenly becomes logical. Now think about this. If lenses can bend and focus light, what happens when light behaves like a wave instead of a straight ray? That's when we enter diffraction, interference, and polarization, the world of wave optics.